All right, so review for the quiz on activities 6 through 8. It's a little bit of everything. Non-calculator portion has 2 questions. You will have to write the equation given a piecewise graph, and the other non-calculator question is a combination kind of these two, where you're going to have to describe the transformation and then graph it correctly without a calculator, which was exactly like how the first 3 problems were on the 8-2 homework. So it's more like that question. It's more worded like that than the way these are. So let's, those are your first 2 questions, non-calculator. So let's take a look at this piecewise graph. I can't erase my thing. All right. So give it a name. Oh, it says f of x. And generally you would write the one on the left first, so that over here your x would be the less than part. If you happen to get that upside down, that's really okay. So, but that's the proper way to do it. So I'm going to start at the left one, or the one that points to negative infinity, which is this one. It's obviously a line, so I know I'm going to have to look for my slope and my y-intercept. The slope looks like -1. You can see it over and over and over again. So it's negative x. Actually, it's down 2 over 1. Sorry, down 2 over 1. So it's negative 2x. And the y-intercept is 0. So we don't have to write that. And then this would be if x is less than. It's less than because it's an open circle and looks like 1. So then the other one starts there. So, but this is x is greater than or equal to 1 because it's a colored in circle. And I'm going to try to back this thing up and try to figure out where the y-intercept would be just by counting the slope the other way. So this is the slope that's 1. So if I go down 1 over 1, it looks like it would go right to -2. So the slope is 1, y-intercept is -2. So this is x minus 2. Now these transformations are designed so you can't put them in the calculator. You won't have the calculator anyway, so it'll be written more like 3 square root of x minus 5, something like that, where you have an actual function inside of it. So this is a vertical stretch of 3 and right 5. And of course, on the test, you'll have to graph it as well. Now, when you write it down, the order doesn't matter how you write it. It does matter the order how you graph it. This one is a horizontal now because it's inside. So you think 1/3, which is small, so it's a shrink. So you think it, but 1/3 isn't in the problem. It's a horizontal shrink of 3. And then, of course, down 5. And then we get to number 3, which I think has a typo in it. So we're having the parent graph of f of x reflected over the y-axis. We're supposed to call it g of x. I guess it doesn't say. I'm going to call mine g of x. And then we're going to have the radical. I know I have this because it's y-axis. Horizontally compressed by a factor of 1/2. Because that doesn't go together. Right? If it was horizontally compressed, it would be a bigger number. So it's either, I think this is supposed to be a 2, honestly. Because you would think 1/2, but you would write the 2. So I think that's a typo because those 2 pieces of information don't go together. And then we're going to go to the left, x plus 2. On the test, you won't have both of these things. You will not have reflect over the y-axis and horizontally compressed. It'll be a little bit better than that. That's kind of ridiculous. On the calculator part, we've got some random questions about functions, honestly. Maybe it's max and min, maybe it's increasing, decreasing, and behavior. And then this one says, describe the transformation that's going to make this even. A quick little graph shows us that it's over here. So basically we need that y-axis to be right here. The y-axis has to go through the vertex. So the fact that it is left 3 is the only part that matters. So in order to slide this thing to the right to make this even, we would need to go to the right 3. This is just putting these in the calculator, which one has a max of 0. It's that one. Increasing and decreasing intervals. Please use correct notation. Just a quick sketch as a point of reference. This is right there at 3. We don't really care how high up it is, but we care that it's right at 3. So this side obviously is increasing. This is your increasing side, and then this is your decreasing side. So we would say increasing for where x is less than 3, and decreasing x is greater than 3. Domain and range for this guy, you can look at the graph because you'll have your calculator. And then take a look at the table, look at the picture, whatever works for you. Two couple of ways you can write this if you want to write it as an inequality. Domain and range, or make sure you use the proper x and y, or if you don't want to worry about x and y, this could be from -5 to infinity, and this one would be from -infinity to -1. And behavior obviously always has that same pattern. I go from the left. You can start any way you want to. So x comes from -infinity, and x is going to +infinity. So if x goes to the left or to -infinity, the y value is going up to +infinity. And if we look to the right for infinity, then y is going down. So -infinity. Absolutely, all of this is on the test. All of this. Graph it, restrict the domain, write the inverse, graph the inverse, give the domain range of the inverse. All those parts. Exactly what you see here. Spelled out this way so that it's not all just in the directions, so that in case you didn't read it closely enough, I don't want you to skip the directions. So put the vertex on here. I'm graphing this function. You'll have your calculator. The graph should be exact. That's f of x. So what are we going to restrict the domain? I'm going to restrict it to the positive so that I don't have to put the negative sign on my inverse. So I'm going to restrict my domain this way. So my domain restriction is going to be x is greater than or equal to 3. To find the inverse, switch the x and y. We'll take the square root first. Because I'm only doing positive, I don't have to put the plus or minus in front of it. If you chose the left side, you better put that negative sign in front of that. I will move that 3 over. And then this is your inverse. So to graph this, and throw it in the calculator, make sure that the -3 is definitely not under that square root sign. So we go to graph this thing. Or you can look at the points or switch your points, right? So it's either way, your choice. And then here. And then there's another one. Here. Wrong spot. Counting problems, sorry. It's right there. This is the inverse. You don't have to label it. I'm just labeling it for your clarity. And then, of course, for the next part, we want the domain and range of the inverse. Again, your choice on notation. So our domain here is going to be x is greater than or equal to 0, or from 0 to infinity. And for the range, we have y is greater than or equal to -3, or from -3 to infinity. This is how this will look on the test too, this next section, where all the functions are kind of up here at the top, and then you can just do some random stuff. It could be anything: add, subtract, multiply, divide, composition, inverse. all the things. Keep in mind some domain restrictions, just in case you need them. This would be x is greater than or equal to -2. Oh, that's a 3. Greater than or equal to -2. And this one would be x cannot equal 0. This matters when you're doing add, subtract, multiply, and divide. Composition, of course, evaluate your domain of your final function and not its parts, because we know they don't resemble it. All right, so for subtracting, please pay attention to your order. This one says h comes first.